Welcome to Jaysan Chemistry. Our next topic is going to be different methods of expressing concentration of solutions. The first one is going to be molality. Molality is denoted by small m, and the next one is going to be molarity. It's going to be capital M, and the third one is going to be normality. Now, what is the definition for these concentration terms? It is denoted by capital N. For molality, small m; molarity, capital M; for normality, capital N. What is molality? So it is going to be the number of moles present in 1 kilogram. Molarity, number of moles present in 1 liter. And normality is going to be the number of moles present in 1 equivalent. In the previous video we saw what is the difference between molar mass and equivalent mass. That means molecular weight and equivalent weight. Now the difference is, this is the number of moles in 1 kilogram, 1 liter. But you remember that 1 kilogram of solvent, this is 1 liter of solution. So that you have to remember. This is going to be number of moles in 1 kilogram of solvent, and this is going to be number of moles in 1 liter of solution. Here you have R in liter, so this is molarity. Here also you have R. Remember like that. Liter you have R, molarity also you have R. So molarity is going to be the number of moles in 1 liter, whereas molality, it is going to be the number of moles in 1 kilogram. Here it is going to be solvent, here it is going to be solution. Normality, number of moles in 1 equivalent. Now I am going to give the formula for all these three. First I am going to give for molarity, which is capital M. Then it is going to be molality, it is going to be small m. And finally normality, and it is going to be N, capital N. So what is molarity? Molarity is equal to weight by molecular weight into 1000 by volume in milliliter. Molality, weight by molecular weight into 1000 by weight in grams. Normality, weight by equivalent weight into 1000 volume in milliliter. Now you see the difference between molarity and molality, right? For molarity we are going to take volume. For molality we are going to take weight. So volume in ml, weight in grams. Others are same. See, weight by molecular weight, weight by molecular weight. The main difference is here it is going to be volume, here it is going to be weight. And this is going to be the weight of the solute and molecular weight of the solute. And this one is of the solvent. Here also this is going to be for solute and this is going to be for solvent. Remember that. Now when you compare molarity and normality, you have volume only, but instead of molecular weight, here you are going to have equivalent weight. And one more thing I am going to say, if the volume is going to be in liters, here you will not be putting this 1000 here. Here also, if the weight is going to be in kilogram, here you will not write 1000. So remember that. Instead of weight by molecular weight, you can just write it as number of moles, because number of moles is nothing but weight by molecular weight, right? The next one is going to be mass percent or weight percent. How to calculate this? It is going to be weight by weight, right? Now what is mass percent? Mass percent is equal to mass of solute by mass of solvent into 100. To express in percentage, you multiply by 100, right? Why we have here weight by weight? This is also taken as mass and this is also taken as mass, right? Now if you want to express it in parts per million, ppm, parts per million. See, for example, you are going to take a water from a pond. They are asking to find out the amount of dissolved oxygen in parts per million. So I will write it in parts per million. It is going to be mass of solute divided by mass of solvent into 10 to the power of 6, because million is 10 to the power of 6, right? So if you want to express it in parts per million, you have to multiply by 10 power 6. If you want it in percentage, multiply by 100. If you want to express it in parts per thousand, then mass of solute by mass of solvent into 1000. So in which way you are going to express? If you are going to express in percentage, 100, in parts per million, 10 to the power of 6, in parts per thousand, it is going to be 1000. So that is the difference, right? Next topic is going to be mole fraction. I am going to give an example for a better understanding. For example, we have three components, A, B and C. The number of moles of A is going to be 1, it is B it is going to be 2, and for C it is going to be 3. Now, I want the mole fractions of A, B and C. What is the formula for mole fraction? Mole fraction is denoted by the letter small x is equal to number of moles divided by total number of moles. So that is going to be the formula here. Now I want to find out the total number of moles. So what is the total number of moles in this case? 1 plus 2 plus 3, which is 6. So the total number of moles is going to be 6. I want to find out the mole fraction of A. What is the mole fraction of A? XA is equal to number of moles. Number of moles of A is 1. Total number of moles is 6. So the mole fraction of A is going to be 1 by 6. Now what is going to be the mole fraction of B? Mole fraction of B is equal to number of moles. Number of moles of B is going to be 2. Total number of moles is going to be 6. In case of C, mole fraction of C is equal to number of moles of C is 3 and the total number of moles is going to be 6. So this is the way to find out the mole fraction. Sum of mole fractions will always be equal to 1. We will check it here. Sum of mole fractions will always be equal to 1. So 1 by 6 plus 2 by 6 plus 3 by 6, which is 6 by 6, which is also 1. So what is the formula for that? x1 plus x2 plus x3 plus etc., which is equal to 1. So sum of mole fractions will always be equal to 1, or you can write it like this also. Sigma xi is equal to 1.